My dear friends, welcome to Rajashekar classes on applied data science with Python. This is lecture number 554. In this lecture, I will continue my discussion on decision surfaces playground or neural network playground. We can increase or decrease number of hidden layers. If I press plus, number of hidden layers will increase. If I press minus, number of hidden layers will decrease. Actually, I want to run this and show to you. I am just leaving everything to default value. The default values are here. I am just taking these two circles. This is my what is my data set? This is my data set, two circles data set. Where it is? This is my, let me choose, this is my data set, isn't it? Now I want to start training. Look at all the parameters. I have noise. Just see, you have noise is 0. Here what it says, your noise is 0, isn't it? Yes. No noise. I have no noise. I have batch size of 10 points. Just check it out. Just see, I have batch size of 10 points, and my learning rate is 0. Your learning rate is 0.03. Activation function is, what is my activation function? Tan H, and no regularization. Just see, regularization none, isn't it? No regularization, and no regularization rate, isn't it? No regularization rate is 0. You have two hidden layers. Just let me take this default one. Yes, this is my default one. Here you have two hidden layers. Here this is two. You have two hidden layers, and this is you have output. Just see, this is my output, isn't it? The fun part that is I really enjoyed is when I run this. Let's run it. What happens? This is the fun part here. Let me let me run this one. How can I run this? Just see, it is simple and straightforward. Just I must press this particular button. This is run button, isn't it? If I press this particular button, what happens? Just see, I am running, isn't it? How many epochs I have run 157 epochs. Just see, I run this particular code for 157 epochs here, which means I have gone through the training data. I have gone through the training data. 157 times. That is epoch, isn't it? Here you can see the dark line is test loss. Here just see, this is test loss. Here you have two lines, dark line and gray line, isn't it? Gray line is training loss. What is your test loss and what is your training loss? Just see, your test loss 0.005 and your train loss 0.03. Both of them are overlapping. Just see, here your training loss and testing loss are, both of them are overlapping here. What it says, just see, if I take on x-axis number of iterations. So both what happens initially my loss was large, but my test loss and training loss, but over a period of time my training loss and test loss are both falling. Just see, over a period of time what's happening here. Over a period of time, this training loss as well as test loss both are falling. Both are what's happening? Both are decreasing, isn't it? And let's take test. Let me say like this. Yes, what it says. My training loss and test loss are both falling. Imagine only if your training loss is falling. Imagine if your only training loss is falling, but test loss is not decreasing. That implies you are overfitting, isn't it? What does it mean? Just say what is the meaning of imagine only if your training loss is falling but test loss is not decreasing, that implies you are overfitting. If you are both training loss and test loss, if you are both training loss and test loss are large, which implies that you are underfitting, isn't it? The final diagram that shows is very good. I have done it for 157. I have done it for 157 epochs using learning rate of 0.03 and activation function tan h. The data that I have here is two concentric circles. At the end of it, this is what my decision surfaces. It says all the points which are here, which are here, remember this whole region is highlighted in blue. What it means, any point which is in this particular region, any point which is here, any point which is in this particular region is, what does it mean? Any point which is here is actually blue point. Anything that is in orange region is an orange point, and the width of this line, actually what is this? This width of the line shows that whether the weight is larger or small. So for example, if I go here, it tells me what is the weight of the edge is. Let me check the weight. Just weight is this width indicate weight is larger or smaller. Just let me take simple example. Just if I take my cursor here, it is showing that 1.4 means weight of this particular edge is 1.4. In similar manner, for this particular edge weight is 0.28, isn't it? You can just move the cursor to that particular edge, you will get the weights. Here you have an edge with weight 0.44. I can actually see the training happening in real time. The fun challenge here, let's say the hardest data set within these four, actually which one is hardest data set? The hardest data set with these four is actually this particular data set. This spiral data set is the hardest data set in given four data sets, isn't it? So now let's train what happens if I am training. Look at it. Let's see what happens here. This is very hard data set. Let's look at it. This whole thing is just let me train this one after 104 epochs. What I am getting here, isn't it? Let's look at this whole thing is blue area, isn't it? This whole thing is I can say orange area, isn't it? There is another region is orange. This one is, I can say, let me say this is orange area. This one is let me say orange area, isn't it? Which is not right. Most important thing that we notice here is, let's look at the training loss and test loss. Just see, I have training loss. This is training loss, and I have test loss. This is test loss. Isn't test loss? I have training loss as well as test loss. The training loss, which is the gray line falling erratically. Just see, gray line is falling erratically. There is a gap between training loss and test loss. Just see, there is a gap between, this is test loss, this is training loss. There is a gap here. Just see the gap, isn't it? The training loss and test loss are not same here. You know that it is overfitting, isn't it? What does it mean? If there is a gap between training loss and testing loss, what is your conclusion? You know that it is overfitting. Ideally, they should very close to each other, like in the previous case. Here your test loss is different from training loss, isn't it? Ideally they should be very close to each other, like in the previous case that we saw. So whatever you do here, it takes lot of efforts to ensure that after a while, the very fact that the gap is increasing, just see, just see, after a while, if you keep after 532 epochs, gap is still is increasing, which implies that you are overfitting more and more, isn't it? What is the meaning of that? You are overfitting more and more. This model is overfitting, and it says the whole blue area is blue. Just see, the whole blue area is blue, and this whole thing is orange, which is not right. Which is, so it's trying to fit with two hidden layers. That's important. It is trying to fit this model with two hidden layers. It runs 1306 epochs. Of course, the loss is decreasing. The loss is only 0.385, and which loss? Test loss, and your there is some two loss, isn't it? 0.306 is training loss, test loss is 0.385, isn't it? Okay, okay, that training and test are coming closer. There is some possibility that may work after a while. You notice that, okay, it's learning something interesting here. It takes lot of time. Again test loss is large, training loss is large. Again the gap increases between the test loss and training loss, and again overfitting. You will run into the problem of overfitting. Now the fun part is this: even after 1000 epochs, even after 1000 epochs, the data set that you have is like this. It says that this region, this particular region is blue region, isn't it? This region is blue region. This region is also blue. This region is orange region, something like that, isn't it? It says that this region. Let me show. This region is blue region. If you observe this one, you have different regions, isn't it? Just see. This is blue region. This is orange region, isn't it? Light blue, you have light blue. Basically says that light blue means what? That is not sure that the whether it is blue or not. Light orange is once again it's not sure. Deep orange basically says that is class 1. Deep blue means it is sure that it is class 0. Others it's not very sure, isn't it? So for this data set of spiral stuff, if you add, let me add sin x1 and sin x2. Just see, for this particular stuff I am adding sin x1 and sin x2. The sin x feature transform looks like this. If you add it and retrain very quickly, just if I am adding again, I am retraining very quickly, no time at all, we will get the structure that you want. Just see, for 122 epochs, just for 122 epochs I am getting the structure which I want. For 122 iterations I am getting the structure that I want. My loss is also significantly lower than previous case. So there is a lot of fun that happening here. Look at it. Just see, just if at 282 epochs my loss is very small. All these points are actually blue. Just see, all these points are actually blue. I can say thick blue here. All these points are actually orange. Just see here, all these points are actually orange, isn't it? By just adding these two features, sin x1 and sin x2, within just 200 epochs, isn't it? Within just 200 epochs I got a much better selection than not having both of them. Not having both of them means not having sin x1, sin x2. It took 1000 epochs without sin x1, sin x2. It took 1000 epochs, and still I was not doing a good job. And very fact that this weight is high. Just see, this weight is high. Just observe, this weight is high. Sin x1 is weight. It's thick weight. This is thick one, isn't it? this weight, and very fact that this weights is high, it is very higher because it is thicker line. Just see, from sin x1 and sin x2 you have got thicker lines, isn't it? The thick line shows that it is very important feature. By just doing simple feature engineering like adding sin x1 and sin x2, we are able to solve much harder problem of the concentric spirals. I encourage all of you to play with this tool. This is one of the best tools through which you can gain deep intuition, change the learning rate. See what happens if you change the learning rate, change the activation function, change the regularization, change the regularization rate. Play with this tool. I strongly recommend each of you at least spend 1 to 2 hours, add noise, change batch size, play with this data. This is one of the best tool that I found in the internet. This is simple multi-layer perceptron. There is a lot of nice documentation is also for this. Just go down and there you can see the lot of documentation here. Just see, if you go down and you can check, I will show that documentation. Let me go to that particular page. Just let me show that page. Just let me go. Just see here, you can find lot of documentation. Just see here, it's what is this, what is neural network, can I represent it? Just see the lot of here I have lot of documentation is also for this. Just go down, just see this one, there is a lot of documentation that you have here. Very beautiful tool and the best tool. Just let me show this one. Just in last class also I introduced it. Just this one, what's happening here. Yes, okay, just let me cut this. Okay, yes, what's happening here, this is my data set. For this, if I run this one, just see what's happening. Just observe this one, this test loss, training loss, isn't it? This you can see the learning rate, activation function. Earlier we have seen, you can see the with sigmoid activation what happens. If ReLU, anyway I will discuss about ReLU. Time being, just let me keep tan H activation function. Just see this training loss and test loss. Yes, you can see the rate of ratio of training to the test data. Just I am not introducing any noise. If you want to introduce noise, you can introduce noise. Just say yes, you can change the batch size. If you want to change batch size, you can change batch size, isn't it? You can make any number of experiments, isn't it? Just if I want to pass this one, I can pass regularization rate. If I want to keep some regularization rate, I can keep regularization, L1 regularization or L2 regularization. You can keep. Just play around this, whether it is classification task or regression task. If it is classification, just select classification, isn't it? Just if you want to take here you have different data sets, make experiment with different data sets. Which one is the hardest data set? We were saying that this particular spiral data set is hardest data set. You can execute with this spiral data set. Even if you want to increase hidden layer, just see, you can increase number of neurons. See, earlier I have, now just I can decrease number of neurons, 4 neurons, 3 neurons, 2 neurons. Yes, even if I want, I can increase. Here also, if I want to increase neurons, I can increase. If I want to decrease neurons, I can decrease. Here you can, if you want to increase hidden layers, you can increase hidden layers. If you want to decrease hidden layers, you can decrease hidden layers. Yes, just whatever you want, you can do it. Just see, if you want to decrease this one, you can decrease. Yes, just make experiment. Just this is the data set. This is spiral data set. Yes, you can execute for the spiral data set. This is what we were saying. This is little bit difficult data set compared to other data sets, isn't it? Now, just what am I doing? Just let me keep some feature engineering stuff here. Let me add sin x1, let me add sin x2. Again let me train this one. What happens? Just see, with the sin x1, sin x2, just you are getting neat diagram. Just see, for only 188 epochs I am getting clean separation of data set. Just you can see the weights here. These weights, sin x1, sin x2 weights are little bit this is thick weights. Just I request you to play around this particular tool. certainly you can get good intuition on decision surfaces. Otherwise, I can say you can understand neural network, how neural networks works. This is, I can say, it is one of the best neural network playground. You can explore different options here. Just explore all the options and try to understand. Just go through this lecture number 553 and 554 are very important lectures through which you will get intuition on multi-layer perceptron, multi-layer perceptron features. What is the data you can understand, what is the epochs you can understand, what is the learning rate you can understand, what is the activation function you can understand, what is the regularization you can understand, what is the regularization rate you can understand, what is the ratio of training and test data you can understand, noise introduction you can understand, batch size you can understand. Just try to go through this lecture. If you have any difficulty, please keep a comment. Thank you very much. In my next lecture, I will start deep learning, deep multi-layer perceptrons. Thank you.